Okay, Ivan.
Okay. I got a set of maps that we'll be looking at as we go through this. I'm going to collect those back after we're done. Renee has a set of the spreadsheets stuff that I've given her. You'll also, this is the actual commission report. The maps will be just for an explanation as we go through the thing of what, how the reclassification is done.
Cutting out a couple trees, didn't you?
Okay. Okay, we're going to first go over the factors used in the classification process again, is what this information is. I'll collect this back again when we're done. But the classification is based upon the benefited acres, then the wetness factor, which is based upon the soil survey for the property. We go through and take a look at the soils, and we classify or assign a drainage need factor based upon the type of soils that they have. And that is a classification that's based on a wetness factor. If you look at the second sheet there, if it's a Okoboji type soil and stuff, it's 100% need of drainage. If it's soils adjacent to the Okobojis, typically they're going to rate as a 70% need of drainage. Nicolette soils, those type of soils are going to rate around a 40% need of drainage, and then clary and ridge tops and stuff are signed off on a 10%. The proximity to outlet, the next factor is how close was the facility actually, that given facility we're looking at, how close was it brought to my property, and that is measured. If you look at your maps, first of all, this map here is just an aerial overview of the whole district system. What you're seeing in blue there is, I'm going to get myself oriented here. The lower stretch is the main open ditch, and then it ends right up here at a head wall structure, and then you have a tile main, and then that was the original tile main system. This is the district that had a relief line put in that goes out to the north. Drainage District 21's tile is this piece of tile that shows up here, and then inside of the district is Drainage District 39. And if you go to, I guess we don't have, yeah, those aren't named right here and stuff. But so basically, this reclassification involved breaking up the district facilities into 4 different schedules. The main open ditch at the lower end, the tile main up to this basically watershed divide, the tile system, which is a combination of, you got two tile lines going out of here. You have the original tile main that was going out to the main open ditch, you get the relief line. So what we did is classify those 2 tile systems for these lands served up here, because they're cross-connected. That is classified to them based upon the benefit from both tile systems acting together. So we call it a tile system. We look at proximity based upon the proximity off of the relief line. We look at usage factor based upon the combination of the 2 tiles together for classifying their usage.
How do you, are they the same, how do you know what goes north and what goes south?
They're acting together, so they're getting the benefit of both. We're not splitting 50% this way, 50% this way in a sense. It's one system that they're doing. And then above that is then what we call the tile lateral, the very upper end. So the tile lateral outletting through the tile system, and then the tile main is this stretch here, and then the main open ditch. So 4 schedules is what is involved in this classification. Okay, we had talked about this map here is what I want to get to for proximity. In the proximity process, we are looking at the flow path system for every piece of ground out there as to how if water gets to the outlet system. And the proximity is based upon how close was the outlet brought to where my water leaves my property. The LiDAR, this map here, looks different than what you've seen in the past. Before, we used to have to draw these flow paths manually, hand drawing them in. With LiDAR data now, what we're able to do is we still have to go through all the field review, look at the watershed boundary to determine the boundary, look at the interior split, to make the sub-watershed areas in there. And then we have to burn in a sense, what we call burn in. We have to locate the intakes and basically the culverts underneath of the road systems, and we have to physically burn those into the drawing. Then when the computer knows this information, the LiDAR gives it an elevation, and this flow path is based upon which way water will flow by elevation from each one of these small, what we call catchment areas that are generated out there. The computer actually looks at the elevation using the LiDAR data and actually generates, says this chunk of ground, water will start leaving in this direction, and draws in the catchment and the flow path as which way that water is leaving. If it has no outlet until it'll pond the water until it starts to break, physically break. So you could have a slough out there that doesn't want to drain surface-wise until it fills up to a certain elevation, and then it takes off. Tile systems also, we have to burn the flow path of the tile system in, but we don't know the private tile systems, but we know the district tile systems. So these flow paths are all based upon surface out to wherever we have a physical district tile system or whatever that it knows is an outlet to it. Okay? So that's proximity. The facility use factor is a factor in regard to taking a look at how much of that facility do you use. If my water is outletting into the main open ditch down here, or outletting way up here at the top end, I only use a portion of that open ditch for my outlet. Up here I'm using 100%. So in the open ditch schedule, there is separate proximity, separate usage computed for the open ditch, because that facility ends here. So from everything up above this is 100% use to the main open ditch. And this usage is computed based upon a computed excavation. How much, assuming the ditch wasn't there, we look at how much excavation would it took dig the ditch, and then we compute. When my water enters at this given location, I'm using 10% of the ditch. That is assigned then to every parcel or piece of ground that's coming in at that given location. So usage is evaluated all along the facility.
Back to your double tile situation to the north then, how do you?
We actually computed a combined usage. We took the sizing of the tile system and lengths of the tile system
per
all the way up.
whatever's available up there.
Right. So these grounds right here on this system here are only getting usage based upon the single line. Once we get to this location, all this ground is, in this ground is getting usage based upon both tile systems.
It's a complicated, it throws a wrench in the
It does. We had to go through a combined usage computation, and then that has to be, each location where this water's coming in, then, there's in a sense a separate usage factor computed for each one of those locations.